Now moving to the second part of the notes, we're going to talk about transformations of parent functions. So a transformation is any shift of your parent function. It could be left, right, up, down, stretch, shrink or stretch compress, or you can reflect. Alright, so now this general setup works for any function. A would be on the outside of the operation. The F in the parentheses is talking about the actual operation. So that could mean the absolute value bars. It could mean parentheses squared, parentheses cubed, cube root, square root, any of those functions that we talked about in the previous video. But shifting can happen inside the operation and then outside of the operation. So A determines whether the graph has vertically stretched or shrunk, and I'm going to use compressed here. H determines whether the graph has shifted left or right, and we've talked about how it's opposite of what you would think because of this negative H. K determines whether we shift up or down, and that is true to its sign. A negative on the outside of the operation demonstrates a reflection across the x-axis. So that would be a vertical reflection. And it's x-axis because here's your x-axis, and if you're flipping vertically, you're flipping over that x-axis. And then this is a new one for us, f of negative x. If the negative is inside the parentheses with x, that's a reflection across the y-axis. So that's a horizontal reflection. So that's just flipping your function over the y-axis horizontally. Alright, so let's do a few examples. We're going to state the parent function and the types of transformations, then graph the parent function and the transform function on the graph below. Also state domain and range. Alright, so we have a lot to do. Let's start with example 1. We're looking at a quadratic, and that is because of this squared here. Okay, think back to the parent function of quadratics, it's x squared. So that's our key. It's a quadratic. We have two transformations. We're going to move right 3 and up 2. I'm going to graph the parent function in a different color. So the parent function is x squared. That's just a parabola sitting at the origin. Now, when I graph the transformed function, I'm going to move 1, 2, 3 to the right, 2 up. That's my new vertex. Nothing else has changed about this, so I'm just going to create that same U shape with that new vertex. So my domain will remain all real numbers. I'm going left forever and right forever. But my range is going to be changed from 0 to infinity. Now it's starting 2 to infinity. So I bracket on 2, going up to infinity. I'm going to skip example 2 for now because that was demonstrated in your last video on absolute value. So take a minute and practice that. It will be completed on the answer key for these notes. And then this last function is square root function. So we know that square root, the parent function, is like a half of a parabola on its side starting at the origin. Transformations here, we're going to the right 1 and down 2. So let's sketch that and then we'll look at domain and range. If I take this starting point and I move it to the right 1 and down 2, we're going to be here with that same general shape. So my domain is going to start at an x value of 1, including 1, and going to infinity. The range, its lowest point is negative 2, and then goes up to positive infinity. Alright, so that's graphing, finding transformations from a function, and stating domain and range. This next section, we are given the parent function, we're given a description, and we have to come up with the actual function. So we're working backwards here. So this first one is talking about a quadratic function. I know that's x squared as a parent function. We're going to reflect it across the x-axis. So that's going to go on the outside of the operation. I'm going to name this f of x. It really doesn't matter. You could put y equals, g of x equals, anything will work. I'm going to put a negative on the outside to represent the reflection across the x-axis. Left 3 and down 2, well, I'm going to need to start a parentheses. X always needs to be part of your function. Left 3 will be a plus 3. Remember, it's opposite of what you would think. To make this a quadratic, we have to have this squared. And then down 2 will be a minus 2 on the outside. Now, if you want to check your work, you can go to Desmos and type that in. Negative x plus 3 squared, and then minus 2. So we see a quadratic function that has been shifted to left 3, down 2, and a reflection over the x-axis, so a vertical flip. So that looks correct. Next is an absolute value function. We know that's just the bars around x. I'm going to make this g of x just to switch it up a bit. You could make it f of x again if you want. I'm going to put bars. Reflection across the y-axis is going to be a negative on x inside the bars. So this is the first time we've seen this in action. We saw it in the notes right up here on that last bullet point. Okay, so the negative is on the x inside the operation. And then there's a vertical stretch by 8, so that would go in front of the function operation. And then last we have a square root function, so that would be square root of x. But we're going to do 3 things to this function. I'm going to name it h of x. So we're going to have the square root function. X would go inside. We're going to shift right 7, so that's going to be a minus 7 inside. We're shifting up 9, so a plus 9 outside of the operation. And then a vertical compression of 1/2, which will be in front of your function multiplied by the operation.